Might Proxima b ever be another Earth-like planet? These are speculations everyone keeps making. The journey for an alternative habitable planet and extraterrestrial life on various planets is something that fascinates people. There have been different speculations, and the fact that there have been signals coming from Proxima b makes people believe there might be more to it. Despite these various signs, we still can't determine whether these are messages from the planet or simply echoes of our own signals. Often, these signs lead to dead ends in the quest for extraterrestrial life. Specialists want to ascertain whether extraterrestrial life exists by verifying if these signals genuinely originate from Proxima b. Recently, the James Webb Space Telescope detected artificial lights on Proxima b. If you're passionate about learning about different planets and our progress in finding extraterrestrial life, subscribe to our channel. We create content about space and discuss advancements in science. If you enjoy this content, leave a comment below and share this video with your friends. Now let's dive back into our topic. Proxima Centauri, located approximately 4.2 light-years from our solar system, is a red dwarf star classified as a G-type star. Thus, the star is known as Proxima Centauri. It is the closest star to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603 based on the stars rising around noon while a few celestial bodies, like the Moon and the Sun, were aligned. Proxima Centauri is also known as Alpha Centauri or Alpha Centauri A. It is a single star system with 4 primary forces of fate aligned in a row. Proxima Centauri is at the center of this system. Apart from the 4 stars, there are 2 faint dwarf stars, Alpha Centauri b and Alpha Centauri c, which make up most of the mass but are too dim to be seen with the naked eye. The system is located 23 degrees away from the famous Big Dipper asterism in the constellation Centaurus. Despite Proxima b being a rocky planet, there is still hope it could harbor extraterrestrial life. The search for life elsewhere has brought scientists to Proxima b. They believe its similarities to Earth's size and its distance from its small star make it a viable candidate for supporting life. While this is all speculative, there is hope that these hypotheses hold some truth. There is still much to learn about Proxima b and its orbit, so stay tuned to find out more. You can also check out some of our other content related to extraterrestrials. Do you truly believe there's life out there? Leave a comment below. What fascinates many people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet orbiting an M-type star, with a mass 1.27 times that of Earth. Proxima b takes 11.5 days to complete an orbit around its star. Discovered in 2016, the planet has been a subject of various studies. Although Proxima b resembles Earth in some ways, certain features make it less ideal for life. For one, the planet is too close to its star, meaning it receives extreme ultraviolet radiation. It is estimated to receive many times more radiation than Earth gets from the Sun. This radiation is so intense that it strips away even the lightest hydrogen particles over time, doing the same to oxygen and nitrogen. While many argue that Proxima b could be habitable because it is at a similar distance from its star as Earth is from the Sun, there's more to consider. Distance alone does not determine whether a planet has water, nor is there evidence of an atmosphere conducive to life. Earth's atmosphere makes it habitable, while Mars does not have a suitable atmosphere. The right atmosphere allows for climate regulation, a water-friendly surface, and protection for living organisms against harsh space conditions. If you're still with us and haven't subscribed yet, take a moment to hit the subscribe button. It helps us create more content like this that you'll love. Now, let's explore why people believe the James Webb Space Telescope will help us determine if there's life on Proxima b. The James Webb Space Telescope was launched in 2018 after being delayed since 2011. Many adjustments were made to ensure it provided accurate images. Scientists explain that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb Space Telescope was specifically designed to observe infrared light. It can capture images of this light on a planet's surface and analyze patterns to confirm the presence of water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that being above Earth's atmosphere avoids distortions caused by atmospheric movement. This allows for a clearer view of deep space compared to most ground telescopes. Another advantage is that Earth's weather conditions do not affect space telescopes, ensuring astronomers get clear readings. However, the main downside of a space telescope is that repairs can be costly if something goes wrong. In some cases, a minor defect in a space telescope has required entire missions into space for repairs. These costs make observing planets like Proxima b challenging. With the James Webb Telescope positioned over 1.5 million kilometers away, farther than any human has traveled, rescue missions are impossible. The James Webb Space Telescope features a larger mirror, allowing us to see back to the beginning of the universe nearly 13.7 billion years ago. The farther away an object is, the farther back in time we see because it takes time for light to travel from the object to us. The telescope's ability to observe the universe in longer wavelengths and infrared light enables it to view more distant galaxies with greater resolution than before. This capability has made observing planets like Proxima b easier by detecting infrared light patterns that may indicate artificial sources. There has been hypothetical work on Proxima b utilizing this sort of light, and most specialists accept it's like Earth's initial days. Concentrates on show that, on the off chance that the night side of Proxima b is illuminated to 5% of the typical daytime brightness, the James Webb Space Telescope could detect the artificial light by 85%. Assuming the illumination reaches 9%, the telescope would detect up to 95%. Despite the fact that 5% light may seem like a modest number, we're discussing light from a star as far off as Proxima Centauri. Compared to our Sun, it's multiple times dimmer, yet we still receive a lot of light from our star. This means that even at 0.1% of brightness, we are still reflected in the stellar light. In other words, assuming Proxima b has any civilization emitting light like Earth, the James Webb Space Telescope wouldn't be able to detect it unless the stars were significantly brighter. This scenario is unlikely given that Proxima b orbits so close to its host star, potentially being tidally locked. This means one side of the planet always faces the star while the other remains in everlasting darkness. A civilization living on a tidally locked planet would likely need to focus on lighting systems and use extremely bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. These are speculations advanced by Tabor and Bend, and there is still no evidence to prove their validity. Earth's illumination is visible from space and is known as airglow. Many people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when seen from 300 miles above its surface. Airglow occurs when particles in the upper atmosphere release light to dissipate excess energy. On Earth, airglow can happen when particles and atoms get ionized by sunlight and recapture free electrons. The glow resembles an aurora, except auroras are driven by high-energy particles from the solar wind, while airglow is driven daily by solar radiation. Since the James Webb Space Telescope's launch, researchers have been studying whether it's sufficient to observe distant planets in faraway universes. Although it's the furthest space telescope launched, it still provides limited data needed to find planets with life in other worlds. There have been discussions about developing larger and better telescopes. These undertakings are often expensive and involve significant trial and error. The James Webb Space Telescope's launch was delayed by 7 years due to these issues. Thus, it is crucial for most researchers to develop better technologies that can be launched further into space. Regardless of this, the James Webb Space Telescope's results are promising. Soon we could know whether there is life on Proxima b and other planets. While work is still ongoing on additional telescopes, it's hoped that the completion and launch of the HabEx Exoplanet Observatory will revolutionize space exploration. The estimated completion time for HabEx is 2035, with a launch shortly after. HabEx will be sensitive to all planets in the universe, and its primary objective is to search for Earth-like planets. Its cutting-edge technology will allow it to measure the spectra of most planets and determine whether they are habitable. HabEx is also believed to have a broad range of astrophysical capabilities, enabling it to study the earliest possible epochs in human history, gather data, and understand the life cycles and deaths of massive stars, as well as the factors that support life as we know it. Though HabEx is still in development, the technology used to create it will allow it to study Earth-like planets with such precision that images from these planets will be incredibly clear. HabEx will be sensitive to ultraviolet, optical, and infrared light. The concept behind HabEx is highly compelling and will transform space exploration as we know it, provided it can be realized. If it succeeds, space exploration will undoubtedly change, and people can expect more information about extraterrestrial life on other planets. It will also provide a clearer picture of Earth, allowing us to look back at the world's history and the changes that have occurred in our environment. LUVOIR, Large UV/Optical Infrared Surveyor, is a smaller version of a telescope but builds on our experience with the James Webb Space Telescope. It has ultraviolet capabilities and is considered the next observatory telescope to be used by most astronomers. Space experts aim to launch LUVOIR simultaneously with HabEx. The large UV/optical sensor will greatly enhance space exploration. Studies conducted with LUVOIR show that it will be able to understand what makes Earth stand out from the rest. Several observations have been made of 28 Earth-like planets, and the results have been promising. With such telescopes being developed, delivering insights about planets like Proxima b could become clearer. Although the James Webb Space Telescope has made significant progress in finding new information about Proxima b, there is still much to be improved. Greater visibility of other planets and the ability to detect atmospheres more accurately are needed to help answer whether extraterrestrial life exists. It will also provide further insights into the planet's history and examine the changes that have occurred over time. Ever wondered what might happen if we found extraterrestrial life? Don't worry. We have videos on our channel that discuss this and much more. Subscribe to our channel and hit the notification button to be alerted whenever we post new content. Is there life beyond planet Earth? The debate about life on other planets has been ongoing for some time now. Many people believe that we are not alone in the universe. There have been theories and claims made for decades, but whether we will ever know if life exists on other planets depends on the kind of research we conduct. Scientists are working to ensure that we have more space telescopes orbiting Earth and other planets. However, these telescopes must be more advanced and look beyond infrared lighting to provide better answers about extraterrestrial life. For now, we watch with bated breath as we hope to determine whether our neighboring planet, Proxima b, harbors any life. To learn more about the James Webb Space Telescope and Proxima b, please subscribe to our channel. We post videos regularly, including telescope reviews and evidence of Earth-like features on other planets as we search for life beyond our world. Recent advances in astrobiology have renewed interest in the potential for life on exoplanets. Particularly Proxima b researchers are exploring the planet's surface features and composition to better understand its habitability. For instance, studies focus on identifying the presence of liquid water, a vital ingredient for life as we know it. Additionally, the planet's atmospheric conditions are a subject of interest. Scientists are investigating how its proximity to its star affects temperature fluctuations and atmospheric dynamics. These factors could determine the viability of habitats, should they exist. The idea of biosignatures, signs of life such as specific gases in the atmosphere, has become increasingly important. Researchers are developing models to predict what biosignature profiles might appear on Proxima b, enhancing the search for extraterrestrial life. Interdisciplinary collaborations among astronomers, geologists, and biologists are crucial for refining our understanding of potential life on exoplanets. These teams aim to devise comprehensive strategies for future observations, using both current technology and innovative ideas for upcoming missions. As we refine our search methods, excitement around Proxima b continues to grow, highlighting humanity's quest to explore the universe and uncover the mysteries of life beyond Earth.